So now we're going to talk about the reciprocal trig functions, and we should remember that reciprocal of a fraction just means we're basically flipping the fraction, so the numerator is becoming the denominator and vice versa. So the reciprocal of a over b is b over a. And the thing with these reciprocal trig functions is that, I mean, it's kind of arbitrary to just say we're going to take the opposite over the hypotenuse. There's no reason that we had to do it in that order. So we could also look at the relationship between the hypotenuse over the opposite or the hypotenuse over the adjacent. I don't know why I put h right here as if this is the hypotenuse, right? We have the hypotenuse here and the adjacent side here, right? So we could look at the reciprocal ratios of the ones we've been looking at. So we're going to start with secant. And secant is the ratio of hypotenuse over adjacent, right? C and S are, what cosine and sine start with. So when we're looking at the reciprocal, we're going to look at the one that starts with the other letter, the opposite letter. I guess that's one way you might remember this, right? So cosine starts with C, so its reciprocal starts with S. And we'll see the same thing with sine and cosecant. Or you could just memorize it, right? Like just whatever you need to do. So let's talk about what the graph of secant should look like. Secant is the reciprocal of cosine. So first of all, the reciprocal of 1 is just 1. So they both have this output at 1, right? 1 over 1, 1 over 1, all right? But then let's say that we look at the place where cosine is 1/2. Well, the reciprocal of that is going to be 2, right? So that's going to create a larger output for a secant. 1 over 2, 2 over 1, right? And then what happens is, as cosine approaches 0, I just picked off this point right here. Let's say that as a fraction, this point is 1 over 10,000. It's really small, right? It's really close to 0. So if it's 1 over 10,000, well, then the reciprocal is just going to be 10,000, right? If we go further and we hit a point where cosine's 1 over 100,000, well, then secant itself has to be 100,000. So as cosine gets smaller, secant has to get bigger. And then at pi over 2, where cosine is 0, right? Well, in terms of the unit circle, it's 0 over the hypotenuse of 1. So secant of pi over 2 is going to be 1 over 0, which is undefined, right? So then there's a vertical asymptote at pi over 2 for secant. So as cosine gets smaller, secant gets bigger. Okay. Now I'm going to clean this up so that all this extra stuff's out of the way. All right, so again, since secant is the reciprocal, we know that whenever cosine is 0, secant's going to be undefined because that's going to cause us to divide by 0. So vertical asymptotes at 3 pi over 2 and pi over 2. All right. We also just pointed out that when cosine's 1, secant's also 1 because 1 is its own reciprocal. And then as cosine gets smaller, secant has to get bigger because they're reciprocals, right? And we're dividing by a denominator that's getting closer to 0, right? As cosine gets closer to 0, we're dividing, and secant, we're dividing by 0, so we're going off to infinity, okay? The reciprocal of -1, which is down here, is also -1, right? -1 flipped is just still -1, but it's going to be the same idea. As cosine gets smaller, secant has to get bigger because they are reciprocally related. And again, as we approach 0, we're dividing by 0, which is causing our output to get bigger. So we're just going to go like this. All right? And then one more time, the reciprocal of 1 is 1, but as cosine gets smaller, secant gets bigger and approaches that vertical asymptote. Okay, so the green represents the graph of secant, while the red obviously represents the graph of cosine, and these should be connected. So if we wanted to do any kind of secant graph, like let's say I wanted to do secant of 5 theta, what I could do is graph cosine of 5 theta first, and then use that to graph secant. So let's graph cosine of 5 theta, some good graphing practice. All right, so first of all, the frequency is 5, so the period is 2 pi over 5. So then when I do this sketch, I'm going to make sure my tick marks are 2 pi over 20, dividing that period by 4 for the 4 quadrants of the unit circle. So I'm going to make tick marks that increase by pi over, not 2, pi over 10. So here's pi over 10. Here's 2 pi over 10, or 5 pi over, or pi over 5. Here's 3 pi over 10. And then here's 4 pi over 10, which is again 2 pi over 5. 2 pi over 5 is one cycle, one period. Okay, so then when we sketch this cosine graph, we're going to start up at 1, down to -1. We have an amplitude of 1. So we go down, and then boom, and then we're back up, and then boom. So then to graph secant of 5 theta, it's the same idea. Whenever we have a 0 of cosine, that's going to make a vertical asymptote. Okay, and then we're going to connect at the maxes and mins because the reciprocal of those maxes and mins are just going to be the same. And then we go off to infinity, right? We approach these vertical asymptotes because they are reciprocally related, okay? So then our secant graph just looks like that, okay? Now if we change this to 5 cosine 5 theta, 5 secant theta, all that does is change the amplitude, right? And rather than redraw this, I'm just going to redo my scale, right? So we'll say that this is 5 now, and this is -5, and then 4, 3, 2, 1, right? -1, -2, -3, -4. All right. So if the amplitude's different, then the only thing that changes is the steepness of the graphs, but the general idea for graphing secant remains the same. Okay. So cosecant is the exact same, but just for sine, right? Cosecant, which is the function abbreviation is this, cosecant theta equals hypotenuse over opposite, which is the reciprocal of sine. So real quickly, we're just going to sketch sine, not even going to put tick marks here. Okay, there's sine, right? It's the same idea. Whenever sine is 0, cosecant has to have a vertical asymptote because we're going to be dividing by 0. Reciprocal of 1 is 1. Reciprocal of -1 is -1. Vertical asymptote here. Okay, vertical asymptote also at 0 because sine is 0 there, right? And then as sine gets smaller, cosecant gets bigger. As sine gets smaller, cosecant gets bigger. Okay, same idea here because we would be dividing by 0. Okay, and then same idea if we have like sine of 4 theta, you would just graph sine of 4 theta, and then to do cosecant of 4 theta, you would follow this same conceptual relationship between the two, right? So we have a graph of sine here, and we have a graph of cosecant. All right, then really quickly, we're not going to do any graphs with cotangents, but cotangents is the reciprocal of tangents, which is the adjacent over opposite, right? So then this is going to be a similar graph to tangents, but instead we're going to have VA when sine equals 0, right? So whenever sine is 0, we'll have a vertical asymptote, right? And at those vertical asymptotes, we're shooting off to positive or negative infinity, okay? And then we'll have x-intercepts of cotangents when cosine equals 0. Okay, that's all. Nope, one more thing. Finding ratios. Okay, so it's just the flip of the other ratios, right? So if I want to find cosecant of pi over 6, I just have to flip sine of pi over 6. So if sine of pi over 6 is 1/2, then cosecant pi over 6 is 2 over 1, right? If cosine of pi over 6 is square root 3 over 2, then secant pi over 6 is going to be 2 over root 3, which if we get the radical out of the denominator, we get 2 root 3 over 3, right? If we have sine of 7 pi over 4, and we know that that's negative root 2 over 2, then cosecant 7 pi over 4 is going to be negative 2 over root 2, which when we get the radical out of the denominator by multiplying by root 2 over 2, we get 2 root 2 over 2. 2's cancel, and we just get root 2. Okay, so if you can figure out your sine, your cosine, your tangent, then you can figure out your secant, cosecant, cotangent by just flipping the other ratio, because again, they are reciprocals.